Hello everyone, this is Mohammad Salman Khan, a graduate student currently pursuing my MS in the field of data science from Institute of Business Administration, Karachi. I had done this project for my course Machine Learning 2. In this project, I have compared different dimensionality reduction techniques and I have used those techniques to reduce the dimensions of different data sets and tried different machine learning algorithms to train on those data sets. So I've been meaning to find a pattern that I can utilize in my practice that will be helping me to uh, get a starting point if I intend to do dimensionality reduction in the future. So for making it a very generalizable statements and conclusions at the end of the project, I have used multiple data sets. I have used 15 data sets in total, seven of which were used for regression analysis and eight of them were used for classification analysis. So I have kept the pre-processing part and all the data manipulation part constant for each of the data sets so that there is no bias in that regard, and each of the data set and each of the process is quite similar for all of the data sets. So let me just let you see what I have done with the pre-processing part. So I have loaded a dataset. This is a dataset taken from UCI. All of the datasets are taken from there. So this is the first dataset, air quality UCI. So we have loaded the dataset. This is what the data looked like initially. So we made sure that there are no missing values and the data types of the columns are appropriate to be used in machine learning approaches. So we did that, and after that we saw a little summary of the statistics so that we know that what are the ranges of different features. It is very important to scale the features so that there is no uh, impact of a feature more than or as compared to other features. So we dropped date column, we dropped time column, and we declared CO, that is carbon monoxide content in the air, to be our label. So there were 9,357 records, and there were 12 independent features and one label, that is carbon monoxide. We splitted that dataset into train and test sets so that we can train on the test and we can train on the training dataset, and then the test data is unknown to the trained model and we can test on it. Then we scale the data sets. So here it is scaling being done, and after that we have applied the dimensionality reduction techniques. We have for regression we have used principal component analysis, that is PCA, and we have made sure that 0.95 or 95% of the variance is being captured in this process. So after the dimensionality reduction in this regard, we have been able to reduce the dimensionality of the datasets from 12 to 5. As you can see, these fives are the columns of the data set that has been reduced. So now if I have to label these columns, there is no meaning attached to it because during the PCA process the technique has just taken all of the dataset all together and just by reducing the collinearity between or correlations uh, between the features, it has reduced the dimensionality of the dataset. And after that I have used another technique, that is SVD, singular value decomposition, and in this we cannot, like in the PCA one, mention that we want to capture this much of the variance, so we have to give a number of features that we want to keep in our reduced data set. So for that I have used a 2 by 3 factor, so that will be a good reduction in the dimensionality. So I have kept it 2 by 3 factor for all of the data sets so that it is consistent throughout the process. So it has reduced the data set into 3 dimensions. After that, we have used these 6 machine learning algorithms in which we have linear regression, KNN regressor, support vector regressor, decision tree, random forest, and gradient boosting. And we have made a custom model of it. I will share a link of this model and all of this code in the description, so that and if anybody is interested in the code, he or she can uh, access it. So by after all that, we have trained all these 6 models onto the original data set. So in original data set we have 12 dimensions, and when we use the original data set to train the models, so we have found these results, like the R2 score for linear regression was 0.52. The best among them was 0.65, that was for random forest regressor. And then we have used random again these 6 models to train on our PCA reduced data sets. So the dimensions have been reduced as the reduced one data set has had. So again, we have found that the R2 scores are quite comparable, not as good as the original data set, but they are quite comparable, and the time taken by each of the model has been reduced significantly, as well as the dimension of the dataset has been reduced. And again, for SVD, the R2 score has a little dropped for this particular dataset. But yeah, so this was the approach. For the classification part, we have also used the LDA method, so that how LDA works is that it separates the data points in it maximizes the separation between different classes of the data set. So each record having a similar class will have the similar values, and if two records have different classes, then after transformation it will be more apart from each other. So we just compiled these results to get a better view of that. So as we can see in this case, the original dataset has been performing the best, and the PCA was the second best, and SVD the worst of them. But the original dataset, we have to cap we have to decide what we want to do with the data. Uh, what is the objective of our experiment, because uh, the original might get the best performance in terms of the machine learning evaluation point of view, but it may take a quite long time for different data sets if we do for a large data set. So in that case, the PCA reduced result might be acceptable. So yeah, so we need to understand the drop in the performance in the PCA is due to the fact that since we are reducing the dimensionality, there must have been some loss of information. So that is a way to comprehend this. Then again, we have repeated the process on all 14 of the data sets. So this is the second dataset. I will not be showing all of the datasets. I will share the link to uh, Excel sheet in which you can find the results of each of the performance on different datasets. So yeah, after that we have done it for classification. I will just give a quick look on one of the yeah, so this is for classification. For this we have used again 8 different data sets, and we have found that this particular uh, data set, the performance of the default, because we have used the default values for each of the model, so they were not very good, and in some of the data sets like this one, the performance was quite good. So we have used this to compare the models. So yeah, so this is it. I will share the documentation, and I've also shared one of the blog on medium.com, in which you can find more of the information about this particular experiment. And if you have any suggestion or advice, you can just comment below. Thank you so much.